Now I want to take a look at the sine of a difference and use the information about 45 degrees and 30 degrees to actually calculate the sine and cosine of 15 degrees. We did 75 in a previous video, so here we go. I want to look at the sine of 15 degrees, and I'm going to think of this as the sine of 45 degrees minus 30 degrees. Because I know information, I know stuff about 45 and 30, and I'm going to use that to get information about 15. So, the sine of a difference is the sine of the first angle times the cosine of the second angle minus the cosine of the first angle times the sine of the second angle. So here we go. I've got a couple of triangles over here that I need to look at. 2 square root of 3. So there's my 45 degree angle, there's my 30 degree angle. So let's see, sine of 45 degrees, 1 over the square root of 2. Cosine of 30 degrees, radical 3 over 2. Cosine of 45 degrees, cosine 1 over radical 2. There's a minus sign in between. And let's see here, sine of 30 degrees is a half. So I have a grand total of radical 3 minus 1 over 2 radical 2. Yay, there's the sine of 15 degrees. Now, how about the cosine of 15 degrees? Right? Cosine of 15 degrees I think of as the cosine of, not surprising, 45 degrees minus 30 degrees. Because I have a formula for how to do the cosine of a difference. Alright, it's the cosine of the first one times the sine of the second one minus, actually it's plus, sine, what am I doing? I've got this wrong. In the sine it was sine and cosine. For the cosine it's cosine cosine minus sine sine, but with a minus sign here that's a plus. So that's sine 45 sine 30 degrees. Yay! So so what? Cosine of 45 degrees, right up here, 1 over the square root of 2. Cosine of 30 degrees, square root of 3 over 2. Sine of 45 degrees, 1 over the square root of 2. And the sine of 30 degrees is a half. And I can combine these together now, and we've got radical 3 plus 1 over 2 radical 2. So we've calculated the sine and now the cosine of 15 degrees. At this point I want to do just one more thing. I want to calculate the tangent of 15 degrees. Now it turns out I'm going to have an identity which does the tangent of a plus b, or the tangent of a minus b. But I don't really use them very often, because if I want to know tangent and I've already got sine and cosine, well goodness, I know that the tangent of 15 degrees is the sine of 15 degrees divided by the cosine of 15 degrees. I don't really feel like I need an extra identity for tangent. But I mean, there is an identity, and we'll go through it in the next video, but I don't need it on something like this, because I know sine of 15 degrees. I just calculated as radical 3 minus 1 over 2 radical 2, and I'm going to divide by the cosine of 15 degrees, which is radical 3 plus 1 over 2 radical 2. And in order to do that, you invert the bottom fraction and multiply. The 2 radical 2's are going to cancel out, and you end up with radical 3 minus 1 over radical 3 plus 1. Now, in general, I'm not big on rationalizing denominators just because, but in some cases, rationalizing actually does make things simpler, more simple. In this case, it turns out it does. So I'm going to just remind you of how we rationalize something with this sum here with a radical in there. What we do is we multiply by 1. You can always multiply by 1 because it doesn't change the value of anything. It just changes what it looks like. And I'm going to use what's called the conjugate of the denominator here. So change the sign in between those two things. So let's make it a minus 1. And here's what we get. I don't know if you can hear the wind blowing, but it's howling outside, and I can hear it. So here we go. both numerator and denominator, I have a binomial times a binomial, so I'm foiling it out here. So radical 3 times radical 3 is 3. I've got a radical 3 times negative 1. I got another radical 3 times negative 1. And I have a minus 1 times minus 1 is plus 1. So there's my numerator. I'll simplify it in a minute. Denominator, I've got a 3. The outsides I have a minus radical 3. The insides I have a plus radical 3. And lastly, a minus 1. The reason why I chose to just change the sign on the inside here, whatever's in between them, is because in the denominator now, the insides and the outside terms will cancel out. These two things go away, right? So, on the top, I've got 4 minus 2 radical 3, and on the bottom, radical 3 minus 1 is 2. Not radical 3, but 3 minus 1 is 2. And actually, the 2 divides into everything up there, and I just get 2 minus the square root of 3. So this is distinctly simpler than what I had up there. They're equal to each other. So this isn't wrong. It's just that this is kind of a nice way to write that answer. All right, there you go. 15 degrees when I know 30 and 45.